Hello guys, welcome back to Self-Help Maths Academy. Today we will discuss about the solution sets of linear system. So let's discuss first what is importantly uh, the discussion. That is, here we will discuss about two types. First is homogeneous and one more is non-homogeneous. Okay. So here in the homogeneous system, if a system is of the type Ax is equal to 0, we call that system as homogeneous system. And a system, if it is of the type Ax is equal to B, then we call it as non-homogeneous system, where X will, A is any m cross n matrix, and X is a vector in Rn, and 0 is a 0 vector in Rm. Similarly, here it is M cross N matrix, X is a vector in Rn, and B is a vector in Rm. So if a system is in this form, X is equal to 0, we call it as homogeneous. And if a system is of X is equal to B, we call it as non-homogeneous. Okay. So now what we do here is, we will discuss, today's discussion is based on the types of a linear system. So that too depending on a solution. And depending on solution, we have two types. That is consistent system and inconsistent system. Inconsistent system. So what do you mean by consistent system then? A consistent system, further we have the division as, a system is said to be consistent if it has unique solution, if it has unique solution or only solution or only one solution, anything you can say, then we call that this particular system is again comes under the consistency. Also it may be having infinitely many solution. It may be having infinitely many solution. So if a system is said to be consistent, a system is said to be consistent, either it has a unique solution or it has infinitely many solution. Similarly, a system is said to be inconsistent if it has no solution. If it has no solution. Okay. So basically guys, so if we just look at these two types, so a linear equation, now we can have three types. So one is a linear equation may be having no solution. A linear equation may be having no solution, or it may be having unique solution, or it may be having infinitely many solution. Okay. So these are the three things what we have noticed. What we have noticed here is, a system is said to be consistent if it has a unique solution or only one solution, or also it may be having infinitely many solution. Then that particular system we call it as consistent system. Whereas a system, if it has no solution, then we call it as inconsistent system. So therefore, the linear equations we have made into three varieties. The linear equations we made into three varieties. That is, either it may be having no solution, or it may be having unique solution, or it may be having unique solution. So what we do here is, today I will take a non-homogeneous system, and I'll just show you how the system, non-homogeneous system, will be having all these three types. Okay, we will understand one by one in detail with the help of example. Okay, so let's begin with our examples today. So then, a first example I will take it for consistent system which has unique solution or only solution. Let's take the example: x1 minus 2x2 plus x3 is equal to 0, 2x2 minus 8x3 is equal to 8, minus 4x1 plus 5x2 plus 9x3 is equal to minus 9. So this is the given system of equation. So first we will write now the augmented matrix for this. So this is the given system guys, and here you can see the coefficient of x1, x2, x3 together, whatever you will write, that is a coefficient matrix, and this coefficient matrix together with this constant, whatever you are seeing on the right hand side, 0, 8, minus 9, that will be called as augmented matrix. So now I will write the augmented matrix. the augmented matrix is, the augmented matrix for the system will be, it is 1, minus 2, 1, 0, then 0, because the coefficient of x1 is here 0, it is 2, here it is minus 8, and here it is 8. Similarly, minus 4, 5, 9, and minus 9. Now you can just observe that the leading element is 1. With the help of this, I will try to make this element 0. I'll just use the row operation, that is R3 changes to R3 plus 4 times of R1. So here you have 1 and here you have minus 4. So with the help of this row operation, we can make this element 0. So first row as it is, 1, minus 2, 1, 0, 0, 2, minus 8, 8, and here it is minus 4 plus 4, that is 0. Here it is 5, you can just do the calculation if you want, minus 5, then plus 4 times of minus 2, it is minus 8. This will be your minus 13 here. Okay. I'm sorry, here it is plus 5, and minus 8, that will be minus 3. Okay, you can just make a changes. Clearly, here it is plus 5 and minus 8. This is minus 3 here. And similarly, you are having 9, here 9 plus 4, that is 13. Okay, then here it is minus 9 and here 0, so it will be minus 9 only. Okay, so now what we do, clearly you can see that in from R2 I can take this 2 out. So what I do here, I'll just I will just take the 2 out from this R2. Clearly, see, from R2 we'll be taking this 1 by 2 times of R2. So what we get here, you can see R1 as it is, 1 minus 2, 1, 0, and here it is 0, 1, minus 4, 4. This is 0, minus 3, 13, minus 9. Okay, so again you can observe that here you are having 1 and here you are having minus 3. With the help of this R2, I can make this element 0. So what I do, R3 changes to R3 plus 3 times of R2. So if I do this row operation, I'll be getting here 1, minus 2, 1, 0. First row as it is, this is 0, 1, minus 4, 4, R3, this is 0, minus 3 plus 3, it is 0. Here you are having 13, minus 12, 3 4s are minus 12. So 13 plus minus 12 will be, it is just 1. And here you can see, it is minus 9 plus 12. So again it is 3 here. Okay. So now clearly guys, with the help of this, you can see here you are having, this particular element you can see, here you are having 1 and here you are having minus 2. So with the help of this, we can make this element 0. So what I do, now R1 changes to R1 plus 2 times of R2 I am doing. This will be giving us 1 minus 2 plus 2, it is 0. And here it is 1 minus 8. 2 times of, 1 minus 8, that is minus 7 here. Correct? Then this is equal to 0 plus 2 times of R2, it is 8. Okay. So this is your R1. So clearly see if any typo happened. So this will be 1 minus 2 plus 2. Minus 2 plus 2 will be 0. And here it is 1 minus 8, that is minus 7, 0 plus 8. Then R2 as it is 0, 1, minus 4, 4. This is 0, 0, 1 and 3. Okay. So clearly what I do here is I'll take this R3 help and I'll try to make this element 0. So clearly what we do here is I'll just differentiate this by a line and we will be taking the next row operation, that is R1 changes to, we'll try to make R1 changes to R1. Here it is minus 7, here it is plus 1. So R1 plus 7 times of R3, and similarly R2 also I will change R2 plus 4 times of R3. Okay. So with this row operations will be getting your final result. You can see here we will be getting 1, 1 plus 0, that is 0. Okay, again 0 plus 0, it will be, there will be no change. Here it is minus 7 plus 7, that is 0, guys. And here it is 8. You can see 8 plus 3 times of 7, that is 29. 8 plus 21, that is 29. And similarly here you're getting 0. Here it is 1. Here it is minus 4 plus 4, it is 0, guys. And similarly, what do you get here? This will be 4, already we have 4 plus 3 times of 4, it is 12. So 16. Okay, then this is 0, 0, 1, 3. Okay, so clearly at this moment I would like to tell you that, so this particular matrix, if you observe carefully, here we are having the leading element of this row, and leading element of this row, and leading element of this row, or column wise if you come, each column will be having a leading element, and the leading element will be called as pivot position. It is called as pivot position. Each leading element we call it as pivot position. And whatever the pivot position columns you are having, all that columns are having the basic variables. They are having the basic variables. Okay, so you can clearly see that each column is having the pivot position. That means each column is having the basic variable. So from this column we will get x1, and from this column we will get x2, and from this column we will get x3. So all are basic variables. Clearly from this x1 is equal to 29, x2 is equal to 16, and x3 is equal to 3. So whenever you, please remember, it's very important note, whenever the columns, each column will be having a pivot position, that respective column is called as pivot column, and that respective column will be having the basic variable. And if a linear system is having only the basic variables, then the solution system is unique. It is a unique solution system, or a system is having only one solution. Okay, and clearly this system is having a solution, therefore it is a consistent system. And again, in consistent, in particularly if you see, it has a unique solution. It has a unique solution. Okay, so therefore a system is consistent, and that too it is unique. So this is one of the example. Okay, so hope the system is consistent and unique solution is clear. Now let me discuss the very important next thing, that is a system is having a many solution, as I told you earlier. So we will discuss now a system which is having infinitely many solution. Again, I'm taking the non-homogeneous system. So let me take this example: 3x1 plus 5x2 minus 4x3 is equal to 7, and minus 3x1 minus 2x2 plus 4x3 is equal to minus 1, and 6x1 plus x2 minus 8x3 is equal to minus 4. So this is the linear system. So if we write again the augmented matrix, then the augmented matrix is, okay, the augmented matrix will look like this. So let's write this augmented matrix. It is 3, 5, minus 4, 7, minus 3, minus 2, 4, minus 1, it is 6, 1, minus 8, minus 4. Okay, so clearly in this example you can see that the leading element here is 3. So what I will do now, with the help of this, I'll try to make this element 0. Okay, so let's use the row transformation. That is, R2 changes to R2 plus R1, because it is minus 3 plus 3, automatically we can make it 0. And similarly R3 changes to, here it is 6, so R3 changes to R3, so it is 6 minus 6 R2 to 2 times of, that is minus 2 times of R1. Okay, so let's do this row transformation. What we get, let's see. So R1 as it is 3, 5, minus 4, 7. This is minus 3 plus 3, it is 0. Minus 2, here you can see, minus 2 plus 5, that is again 3. 4 minus 4, that is 0 again. Here you can see minus 1 plus 7, that is 6 here. And from this 6 minus 6, that is 0. And 1 minus Here you can see it is 1 minus 2 times of 5. So 1 minus 10, that is minus 9 here. Okay. So here you will be having minus 8 plus 8, that is 0 again. Here it is minus 4 minus 2 times of 7, that is minus 14. So it is minus 18 here. Okay. So this is the changes. So clearly what we do from R1 and from R2 and R3, you can take some elements common. Okay. So let's see what are the elements we can take out. So clearly, if I do the row transformation here from this R2, I can take this 1 by 3 out, and from R3 I can take that minus 1 by 9 out. Okay. So if I do that row transformation, I'll be getting here 3 5 minus 4 7. This is 0 1 0 2. This is 0 1 0 2. Okay. So now guys, you can just do again R3 and R2 I can utilize. And now see, with the help of this R2, I'm making this element 0. That is R3 changes to R3 minus R2. If I do this, I'll be getting here it as 3 5 minus 4 7. This is 0 1 0 2 0 0 0 0. Okay. So clearly, again, if you want, you can just continue with some more row operation, but not necessary to do. Okay, we can stop at this point, or if still want more clarification, we can do some more row transformation. Like, see, I'll just continue. You can stop at this point, but still, what I'll do here is, with the help of this, I can make this element 0. That is R1 changes to R1 minus 5 times of R2 I will do. Okay. So here it will give me 3, 5 minus 5, that is 0, minus 4, this is 0 again. And here it is 7 minus 5 times of 2, 7 minus 10, that is minus 3. Okay. So this is 0, 1, 0, 2. Okay. And this is 0, 0, 0, 0. The last row is completely 0. And now we can clearly observe from this, guys. So whatever the matrix I have here, clearly you can see that here is the pivot position. If still you want, you can just write a solution right now. Here you can see that there is a pivot position or a leading element in this particular row. There is a leading element in this particular row. But next, if you see, there is no leading element in this particular row or in this column. So that implies, as I already told you, if there is a leading element, so therefore these two columns are having the leading elements or the pivot positions. So therefore they are having basic variables. They're having the basic variables. Where there is no leading element or where there is no pivot position, then that particular column will be having the free variable. It is having the free variable. So if I write this as a solution, if you can observe this, if I write it as a solution, let's see how it will come. It is 3x1, this is 3x1 plus this is 0 times of x2, okay, plus minus 4 times of x3 is equal to minus 3. Okay, so this is what you are having here. And similarly from this, what do you have? If the same thing, you can write it as 3x1 minus 4x3 is equal to minus 3. And similarly, what do you write here? This will be x2 is equal to 2 here from this. And from this what? Since it is 0 is equal to 0, that means x3 is free variable. x3 is free variable. So you can see that you can write your 3x1 as minus 3 plus 4x3, and x2 is 2, and x3 is what? Free variable. So as I already told you, if there exists at least one free variable, if there exists at least one free variable, means if I substitute x1, say x2, x3 is equal to 1, one set of solution you will be getting. If I substitute x3 is equal to 2, another set of solution you will get. So the same thing, if I want to write it as the vector form, like see, if I just write it in the form of vector, how it looks like, the solution will be parametric vector form if I write. So your solution is x1, x2, x3. Okay. So what is your x1 here? Your x1 is, if you just divide this by 3, your x1 will be minus 1. Here you can write from this your x1 will be equal to what? It is minus 1 plus 4 by 3 x3, and x2 is 2, and x3 is what? x3 is free. Okay, so here I'll write x1 as 4 by 3 x3 plus 1, and x2 is 2, and x3 is x3. Free means that only I will write. Okay, so clearly if I write again further this as a solution, you can see I split it into two. It's a parametric vector form. This we will write it as x3 into, what we have here is 4 by 3. There is no x3 term is here, 0. Here it is, x3 is 1. x3 into 1 plus the constant term I'll write here, 1, 0. This is 2, and here it is 0. So this implies if I put x3 is equal to 1, I'll get one set of solution. If I put x3 is equal to 2, another set of solution. If I put x3 is equal to 4, another set of solution. Like this, how many solutions are possible? There are infinitely many solutions are possible. So therefore, if there exists at least one free variable, then there are infinitely many solutions. So this is one such example. Here we're writing the solution in the form of parametric vector form. So whatever the solution you have got, right? X we are writing it as p plus t into v form. Okay, so p is one vector, t is another vector. You can see that is you are writing here. This we are writing in the form of p plus t into v. Okay, so this is how we'll be writing the solution. Okay, so this is one such example for many solution. Now I'll take, lastly I will just explain you how about the inconsistent system. Okay, and we will finish our discussion. So the inconsistent system is, directly I will take one example. Here this system will looks like this. I'll directly write a augmented matrix itself. So here if suppose say 0, or if you want you can write the system first, no problem. Here we can write it as x2 minus 4x3, this is equal to 8, and 2x1 minus 3x2 is plus 2x3 is equal to 1, and here we have 5x1 minus 8x2 plus 7x3, this is equal to 1. So this is the system which has been given. Let's write the augmented matrix. Then the augmented matrix will be equal to, this is 0, 1, minus 4, 8. This is 2, minus 3, 2, 1, 5, minus 8, 7, 1. Okay. So since the leading element itself is 0, I'll just do the transformation of a row. R2 and R1 I'll interchange. So this will give us 2, minus 3, 2, 1. This is 0, 1, minus 4, 8. This is 5, minus 8, 7, and 1. Okay. So clearly this with the help of this we can make this element 0. I'll just do this operation, that is R3 changes to, this I multiply with 2, this I multiply with 5, that's it. Okay, R3 changes to 2 times of R1, okay, 2 times of R3, if I multiply this with 2, minus 5 times of R1. Okay, so if I do that, let's see what we'll get. This is 2 minus 3, 2, 1. This is 0, 1, minus 4, 8. And this is 5, that is 5 into 2 is 10, minus 5 into 2 is 10, that is 0. And here you can see you're having minus 8, minus 8 times of 2, then minus 5 times of minus 3. So it is minus 16 plus 15. This will be equal to minus 1 here. And similarly here you are having 7 into 2, or 2 times of 7 minus 5 times of 2. So 7 2s are 14. Here you can see this is 7 times 7 times of 2, or you can say 2 times of 7 here, minus 5 times of R1, that is 2. So 14 minus 10, that is 4 here. Okay, is 2, what do you have? Here you are having 1. This is 1, that is 2 times of 1 minus 5 times of 1. Okay, so yeah, this will be giving you 2 minus 5, that is minus 3 here. Okay, so clearly with the help of this, what I do, R3 changes to R3 plus R2 I'll be doing. So this will give us 2 minus 3, 2, 1, 0, 1 minus 4, 8. This is 0, 0, this is 0, minus 3 plus 8, that is equal to 5. So clearly if you see guys, you in the last row you're having the row of the type 0 0 0 comma 5. So here whenever you're writing a solution, there is a theorem or there is a property in any linear system. When you do the row transformation, if you got any row of the form 0 0 0 b, if you have any row of the form 0 0 0 b, then that system is inconsistent, it has no solution. So what do you mean by this? If you equate it, what do you get? You get here 0 is equal to 5. 0 is equal to 5 means what? It is a contradiction. 0 cannot be equal to 5. This is a contradiction. Contradiction means what? It has no solution. If it has no solution means the system is inconsistent. So like this guys, and clearly you can see that the system is inconsistent and it has no solution. So today what we did is we have discussed about three systems. One is which is having unique solution, and one is it has many solution, and one is it has no solution. So unique solution means there are all the variables whichever you're getting are basic variables. Many solution means at least one variable is free variable. No solution means you're getting a contradiction. So these are the three important discussion we did in the today's class by taking the non-homogeneous system. We taken the non-homogeneous system. In the next discussion, we will take the homogeneous system and we will discuss about its solution. Okay. So if you have any doubts, anything, please comment in the box. If any questions are there, please comment it in the box. If you like the video, please subscribe the channel. With this, we conclude today's discussion, guys. Please take care and see you all in the next discussion. Till then, take care.